All right, hey everybody. Let's see if we can explain some of the earthquake-resistant features that are part of some of these traditional Japanese Minkas. So here we are looking at one side of the second floor of the house here, and I'm gonna use some of the footage from the second floor because I haven't taken down any of the earth wall, any of the tsuchikabe from the first floor yet, so it's easier to see the construction of things up here. Some of the things that we can look at here, maybe I can back up a little and you can get a better view on what we're looking at, but you've got the wall going from one side, the front of the house, to the back of the house here, and this side, all of the earth is still in place there. But what you find when you open up the wall is that you've got this bamboo lattice in place, and the earth is stuck to that. But then if you look down here, you can see where the bamboo lattice is tied around this horizontal section here. This is called the nuki, and this is going through the center of the vertical posts here along the wall. So you can't see it behind the earth wall here, but it's actually coming along here, and it's continuing all the way through each of these vertical posts, all the way to the corner post back there. And then that nuki, if we can get a view of it here, is wedged in place here. And you can actually see, if we turn around to the other side, I've removed the bamboo lattice all the way across the way here. So you can see where the nuki comes in and is wedged into each of the vertical posts here. You can see the wedges there on either side. And what that's going to do is, in the event of an earthquake, is as the structure kind of shakes or flows with the energy of the earthquake, that nuki that's in there kind of gets pinched in between, and as it sort of bends this way, then the natural flexibility of the wood wants to bring it back to straight. If it goes this way, it kind of brings it back to straight, and it keeps the house from falling completely over. And in the event of a big earthquake, even if the final result is that your house gets quite badly damaged, or even eventually sections of it collapsed, the way that this structure is built gives you a lot of time and a lot of warning as to what's going on. So you've got, in general, the idea is that you'd have plenty of time to get out of this house before anything bad happens, anything collapses or breaks on you. But in the event of a regular sized earthquake or whatever, the design is to sway with that energy and hopefully return back to straight. But if not, at least it can be repaired and brought back into position at a later time. Okay, let's take a look at another one of the features of these traditional buildings, and that is that there is no foundation all the way across the building. Your vertical posts are resting on these stone foundations just directly under each of the vertical pillars. And this traditional construction technique is called ishibatate, ishibatate dentou koho. And the pillars are, as you can see if I get a little closer here, are just directly on top of the rock. And what that allows for is, in the event of an earthquake, obviously the ground here, including the stone, is going to start shaking and moving. but with the vertical post not directly connected down to any sort of, concrete foundation with a bolt or anything like that, it allows the ground beneath to sort of move where it needs to move, and the structure up on top, not being fastened to that, is independent of it. And therefore a lot of that energy that comes with the earthquake is dissipated just in the movement of the ground, and not even directly transmitted to the structure of the building itself. Obviously, that can cause the building itself to, in the event of a big earthquake, to shift off of these stone foundations. But at least if your house is intact, that can be remedied as well. I think another aspect of these traditional buildings that's worth mentioning is the earth wall. The bamboo lattice and earth packed in between also acts as a strengthening agent and resists the forces of the earthquake until that earth, if it reaches a level of earthquake that the wall can't handle, then it eventually sort of breaks apart and often will come away from the wall. But then you have the other additional backup, or not really backup, but the other features of the house that also help improve the earthquake resiliency. But the earth wall construction is also a part of that earthquake resilience. So another of the aspects of the earthquake resilience is the fact that there aren't any sort of metal fasteners holding all of these individual pieces together in any really sort of solid way. They're all using the same material. It's all wood, and therefore that wood has its inherent flexibility, which allows those joints again to move and dissipate some of the energy of the earthquake, as well as sort of flexing rather than sort of trying to stay as rigid as possible until the point where it can't hold anymore, and then it just suddenly snaps, which is sort of the technique that a lot of the sort of modern construction uses. Is everything is bolted down and bolted together, and it holds up well until it doesn't, until that level of tolerance is exceeded, and then it can fail sort of suddenly and catastrophically. Whereas these traditional structures are designed to flow with the energy of the earthquake, and hopefully give you some sense of what's going on, give you enough time to make an exit from the building and save yourself. And then hopefully the building is safe in the end as well. But obviously the most important factor is that you're okay and your family's okay, and you have time to get out safely.